Well, today we're going to be learning about angles of polygons. These are our content standards and our mathematical practices that we'll be using in the assignment today. You have previously named and classified polygons. Now we're going to find and use the sum of the measures of the interior angles of a polygon, and we're going to find and use the sum of the measures of the exterior angles of a polygon. We have one new vocabulary word, diagonal. Now, a diagonal of a polygon is a segment that connects any two non-consecutive, so it's not P to Q or P to T because they're consecutive, but any two non-consecutive vertices. A diagonal of a polygon is a segment that connects any two non-consecutive vertices. The sum of the angle measures of a polygon is the sum of the angle measures of the triangles formed by drawing all the possible diagonals from one vertex to another. Since the sum of the angle measures of a triangle is 180, we can make a table and look for a pattern to find the sum of the angle measures for any convex polygon. And here's our table. A triangle has three sides, so n minus 2, 1 times 180 is 180. The sum of the interior measures will be 180. n minus 2, so 4 minus 2 will be 2. 2 times 180, a quadrilateral has 360 as the sum of the interior angle measures. This is a chart that would be very good for you to put in your notes. You can use the polygon interior angle sum theorem to find the sum of the interior angles of a polygon and to find missing measures of polygons. So we're to find the sum of the measures of the interior angles of a convex nonagon. How many sides does a nonagon have? Well, it has 9 sides. So we're going to use the polygon interior angle sum theorem to find the sum of its interior angle measures. A nonagon has 9 sides. 9 minus 2 is 7 times 180. So the sum of the interior angle measures is 1,260. Now we're going to find the measure of each interior angle of this parallelogram, our STU. So first of all, how many vertices are there? It's got 4 sides, so n is equal to 4. So the sum of the measures of the interior angles is 180 times 4 minus 2, or 180 times 2, which is 360. So we can write an equation to express the sum of the measures of the interior angles of a polygon. 360 is equal to the measurement of every angle added together. We substitute in what the measures are that are given to us on the diagram. We combine our like terms. So we're going to subtract 8 from both sides and divide by 32. So now that we know that x is 11, we can substitute 11 for x to find out what the measure is of every angle. Okay, time for you to check your progress. So here's the first of the check your progress. Pause the video for a moment, and then come back and check your answer. Did you get 1,080? You need to find out how many sides an octagon has, which is 8. 8 minus 2 is 6, and 6 times 180 is 1,080. Very good. Find the value of x. So pause for a moment, then come back and check your answer. Did you get 15? Well, we've got 4 sides, so 4 minus 2 times 180 is 360. So we know the measure of the interior angles is 360, and then we just add all the 10x plus 6x plus 6x plus 3x minus 15 together. That equals 360. We'll end up with, when we combine our like terms, 25x minus 15 equals 360. Add 15 to both sides. We get 375, which we then divide by 25. X is 15. Here's a quick chart of the number of sides, the type of polygon. So you might want to put this in your notes as well. Now recall from lesson 1-6 that in a regular polygon all of the interior angles are congruent. And you can use this fact and the polygon interior angle sum theorem to find the interior angle measure of any regular polygon. So here's a real-world example. A mall is designed so that 5 walkways meet at a food court that is in the shape of a regular pentagon. How many sides does a pentagon have, folks? 5. 1, 2, 3, 4, 5. Find the measure of one of the interior angles of the pentagon. So as we study the diagram, the measure of the angle of a corner in between 2 walkways is the interior angle of a regular pentagon. So we're going to use the polygon interior angle sum theorem to find the sum of the measures of the angles. Since the angles of a regular polygon are congruent, divide this sum by the number of angles to find the measure of each interior angle. What does that look like? We know that n minus 2 times 180, in this instance we've got a pentagon, 5 minus 2. So we're going to have 3 times 180, which is 540. So that is the measure of the interior angles of a pentagon. Now we need to find the measure of one angle. Well, if all 5 of them are 540, we simply are going to take it and divide it by 5, because a pentagon has 5 sides. So 108. So the measure of one of the interior angles of the food court is 108. We can verify the measure is correct using a ruler and a protractor to draw a regular pentagon using 108 as the measure of each interior angle. The last side drawn should connect with the beginning point of the first segment drawn. Okay, time to check your progress. So pause for a moment, read through the problem, and come back and check your answer. Did you get 128.57 degrees? Well, let's see. A heptagon, if we look back at our chart from our notes, a heptagon has 7 sides. 7 minus 2 is 5. 5 times 180 gives us 900 divided by 7. Each angle is 128 and 57 hundredths of a degree. Now, given the interior angle measure of a regular polygon, you can also use the polygon interior angle sum theorem to find a polygon's number of sides. So, we are given the measure of an interior angle of a regular polygon is 150. We have to find the number of sides now. So we're going to use the interior angle sum theorem to write an equation to solve for n. So we know that the number of sides is 180 times n minus 2, or for the sum is 180 times n minus 2. If we know that the measure of an interior angle is 150, if we multiply that by the number of sides, isn't that equal to 180 times the number of sides minus 2? So instead of s, we can use 150n in this particular case, because this regular polygon has 150 as the measure of one interior angle. Use the distributive property. Here we're going to add 360 to, well, we subtracted 150n, and then we add 360 to both sides, so we're dealing with positive numbers. Divide both sides by 30. So this polygon has 12 sides. So time to check your progress. So pause for a moment, then come back and check your answer. Okay, did you get 10? So we have 144n is equal to 180 times n minus 2. So 144n is equal to 180n minus 360. We're going to subtract 144n from both sides, add 360 to both sides. So we have 360 is equal to 36n. Divide both sides by 36. N is equal to 10. Very good. Now, does a relationship exist between the number of sides of a convex polygon and the sum of its exterior angle measures? Notice these are exterior angles. This side continues on, so we've got exterior angle measures. What do you notice? Examine these polygons in which an exterior angle has been measured at each vertex. Notice that the sum of the exterior angle measures in each case, in every case, is 360. This suggests the polygon exterior angle sum, where the exterior angles of all the angles of a convex polygon is going to equal 360. Look, we're going around in a circle. A circle is 360, isn't it? Just think about that. So find the value of x in the diagram. Okay, so we know that all of them added together is 360. So all we have to do is actually add them all together. So we're going to combine our like terms. 31x minus 12 equals 360. Add 12 to both sides, divide both sides by 31. So the answer is 12. Okay, very good. Let's find the measure of each exterior angle of a regular decagon. Okay, so a regular decagon has 10 congruent sides. So 10n is equal to 360. So we're simply taking 360 and dividing it by the number of sides so that we know the measure of each exterior angle of a regular decagon. Regular means they all have the same measure. It's 36. Okay, time to check your progress. So pause for a moment, then come back and check your answer. Okay, on this one, you remember that all the sum of the exterior angles of a polygon is 360, so we add them all together. We end up with 25x plus 10 equals 360. Subtract 10 from both sides, divide 350 by 25, and we find that x is 14. So time for us to find the measure of each exterior angle of a regular pentagon. Let's pause for a moment, then come back and check your answer. Okay, do you remember a pentagon has 5 sides? So 5n is equal to 360, so n is equal to 72. Very good, so you're ready to begin your assignment.